Hello, my name is Leonard Kleinrock. I'm chairman of the Computer Science Department at UCLA. We have here a really exciting and dynamic environment. And one of the activities that contributes to that environment and that excitement is the constant flow of visitors who come and spend time with us and interact with our faculty and student body. Each year, we select a few from among the very best researchers in the field and ask them to participate in our distinguished lecture series. The high point of their visit is the presentation of a lecture to our faculty and student body. And at that lecture, they present the state of the art in their field of specialty. They describe the research results, the open problems, and the directions in which the field is likely to go. And as you might expect, these lectures always generate a great deal of enthusiasm and interaction. I'm really pleased you have chosen to join us today. Let's go inside. The lecture's about to begin.
All right, welcome to the beginning of the spring quarter. And we're kicking it off very nicely this quarter with another one of our distinguished lecture series. Today we have a very, very distinguished lecturer, someone I know from many years ago, Bob Luckey. And as is your fate and my pleasure, I'm going to go through a description as to what made Bob Luckey what he is today. So I asked Bob Luckey earlier this morning, what made Bob Luckey what he is today? And he gave the short answer, blind luck. He was always fascinated with electronic junk. And he built the crystal radios of his time, but they never worked. He doesn't believe that cat's whiskers make a crystal or a diode. Some of the rest of us had crystals that worked, but never worked. He never, quote him, he never got nothing out of it. He didn't have a background of science in his family. So it wasn't from there where his capability came from. It came from his innate curiosity. He was always interested in science kinds of things. But what turned him on was one day in the library, he found a book entitled Boy's First Book of Radio. And he remembers the author's name was a fellow named Morgan. And that turned him on. He began to build radios. He would visit Radio Row down in New York City, Canal Street and Cortlandt Street, for the few of you who may know where that is. In those days, you could buy vacuum tubes out in a cardboard box lying on the street. 5 cents, guaranteed to light. That's all they would do. And now try to find out what's wrong with your radio without measurement tools. Those are the days. Okay? As Bob says, and I agree, people don't do that anymore. They don't tinker at that level. What's happened is that PCs have become the toys of the day, and the things that occupy your attention and suck you in. And unfortunately, there was an early period in the history of PCs when you actually got your hands dirty. You don't get your hands dirty anymore. You don't get in there with a screwdriver and get shocked and smell the solder and blow out a circuit or whatever. And in some sense, it's a shit. But those days are vanished. They're gone. In high school, Bob took physics, chemistry, mathematics. And he didn't know what an electrical engineer was. He didn't know what an engineer was. Didn't know he wanted to be an electrical engineer. But unfortunately, he got good grades in high school. The teacher told Bob's father that Bob should be an engineer. Bob still didn't know what an engineer was. Okay? But his father said, you should be a mechanical engineer. And Bob revolted and became an electrical engineer. That was the first revolt of Bob's life. But the engineers in those days were tinkerers. They were people who fooled around with things. But an engineer was an elaboration above that level where you abstracted the things that the tinkerers did. And you managed to abstract so much out of it that the people who really understood what engineering was about, the ham radio operators of the day, who went to the colleges, flunked out because they couldn't do the math or the abstraction. They understood what was happening physically. But all those of us who could do the mathematics well succeeded where they failed. It was, again, kind of a filtering process, which in fact was a very bad filtering process. He then went to Purdue, got 3 degrees in EE, on up to PhD. And his PhD thesis, of course, was groundbreaking. At that time, he combined phase and amplitude modulation to create what we now know as signal constellations, which is the basic means for the way your modems work in all your PCs and the PCMCIA cards and all the rest. an idea that still lives today. It's got a 30-year life and still going strong, so strong that Codex Corporation was a patent on this idea. And their competitors have armies of lawyers suing each other over the royalties that Bob created in his PhD dissertation. And what they're trying to do now, these lawyers, are trying to figure out what was in Bob's head at the time he disclosed his work. He doesn't remember, but they're going to figure it out for him. Another example, while in college he worked at Westinghouse. He had to build an AC to DC converter for a submarine application. And people had done a lot of experimental circuits, because Bob was now an engineer, studying engineer, and he was going to take it from the academic point of view and the mathematical and conceptual point of view. And he tried to suggest this was an approach to designing these circuits to his coworkers, and they basically ridiculed him. So fortunately, one day he had a toothache. He stayed at home in his backyard, and he came up with a world-class idea as to how to synthesize these circuits, basically generating a voltage which was independent of the load. Made the converter work, the engineers saw it, they loved it, they built it, and it became a big success. Meanwhile, Bob went back to college. Years later, he was browsing through a bookstore. He found a handbook, a reference handbook on engineering, and he found his circuit in this book years later. And this was called the famous OTT circuit, OTT, gentleman named Mr. OTT. It was Bob's idea. OTT got the credit. Lesson number one, credit is a very elusive thing in this field. And this theme runs through to the final message you're going to hear from Bob. He then went on to the mecca of research in 1961 when he got his PhD, Bell Labs at Murray Hill. To meet the god there, or tried to meet the god there, Claude Shannon. Claude Shannon was the kingpin at Murray Hill at the time. Turns out in 1961, Claude Shannon had only a virtual presence at Bell Labs. He was physically at MIT. But the people at Bell Labs thought so much about Claude, they kept this virtual presence around and the mystique of Shannon being there. Bob finally met Shannon in 1984 at the IEEE Centennial. While there, though, he did the work for which he is most well known. In 1964 and 65, he developed what was then known and now known as the Adaptive Equalizer. That which has made all of our modems, all of our channel equalizers work as well as they do. Every one of you have touched an adaptive equalizer if you ever touched a PC transmitting over the phone line. Now, how did that develop? Well, one day he was heading home, hit a red light in Red Bank, New Jersey, and had a chance to think. And he saw the answer as to how to build an adaptive equalizer. And it was not by a closed-form solution and a finite circuit, but it was an iterative approach, using steepest descent in a convex space. Just generate the solution on the fly. The adaptivity was a dynamic application. It was a great idea. He stayed up all night waiting to tell people at Bell Labs about it. He put it on a computer. He proved it would work. And fortunately, to the credit of those people, the hardware people agreed, yes, this is a good idea, and immediately took off. Now, Bob came at that from a mathematics point of view, not from an engineering point of view, and there was a success there. And the way in which he presented it was to basically do a mini-max solution, which had an elegant mathematical structure to it, rather than minimizing the mean square error, which was a kind of engineering solution. Turns out that they tried to promote this as a mini-max solution, but the real kick came when they showed it was a minimum mean square solution. Here again, promotion mattered. The mini-max approach didn't garner the kind of exposure that the mean square error would have and could have. So in some sense, from a promotional point of view, it was a mistake. From a scientific point of view, it was a great success. And Bob credits that night and that morning as the best day in his life. He had this idea, he was burning with it, he knew it would work, he proved it the next day and convinced the world about it. He then rose to become executive director of communication science research at Bell Labs. There were 4 directorates: physics, chemistry, computer, and communication science. And he was head of the communication science effort. He left in 1992, a couple of years ago, to become vice president of applied research at Bellcore. So what is Bob's message? It's a long message. It starts off with a key idea. There are 3 things that count in life: luck, being in the right place at the right time, and basic communication skills. And they're all necessary. Okay? You can't have a great idea and then let somebody else take it over, Mr. Ott. Presented the wrong way, Minimax. Okay? You've got to have it all. And in fact, he also points out, I said, what are we going to tell these guys about your experience? He says, well, what he and I have learned is not relevant. You can't learn from history in these days. He quotes Ron Royer at a meeting of EE heads, who was asked, what are we educating people for these days? What are we teaching them? What are we teaching them for? The comment was, in the old days, we teach them to do design work for some large company. That's the model in which we grew up. Today, you train people to do sales and marketing and software for a startup company. Very different set of training and philosophy. He feels that our background, books, producing papers, peer review, publications, the world doesn't work that way anymore. We're considered dinosaurs. Operating that way. Thanks, Bob. The important thing is impact on the world. And in that, of course, he's correct. He still believes in our way of doing things as an act of religious faith, not as an act of practicality. The problem is there's a separation between our academic papers and the way things really go on in industry. You students are caught in that transition. What to do about it? Lifetime employment in one company solving grand problems over a lifetime employment, independent of where the financing comes, then days are gone forever. Okay? Today, you've got to sell your ideas, good communications capability, with luck, and you got to do something. You got to accomplish something. You got to accomplish anything. Okay? In fact, another manager he spoke with, he asked, how do you recognize the people in the organization? He says, I remember somebody, if they'd done anything, something, they have to distinguish themselves out of the crowd. These days, when you're one programmer out of 1,000, or one engineer in a 1,000-person project, how do you distinguish yourself? When he went to Bell Labs, the directory was a thin directory full of very famous names. Now it's a fact directory full of names nobody knows. Okay? Bob, you can finish the story and tell us how to correct it.
Who was that? It's pretty tough to be upstaged by your own biography. I was recalling a time once when I introduced Isaac Asimov at a banquet, and I did a number on him, and he really did not appreciate it. I mean, he wanted to be the star. I want to be the star. I mean, so he really didn't appreciate it. But what I remember particularly about that night is that Asimov gave me his business card, and it is the best business card I have ever seen. It says, Isaac Asimov, genius. If you can do that. I once wrote an article about biographies, and they're usually so dry and boring. When we all fall into this, it's part of this whole business of being really uptight about who we are and professional and stuff. You went to this school, that school, you got this degree, you got this job, and that's all, that's your biography. And he says, is this me? Is this my life? And I propose that everybody should be entitled to one line in their biography to make it interesting. Of course, the problem would be figuring out which was the lie in any given biography. But I often wish that people would put interesting things in their biography, and so seldom do we actually do it. And now I understand why. After hearing this, but no, seriously, that's nice. I could even get some insight to that for a dinosaur. But I do often feel like a dinosaur. And I was thinking of sometime, it's probably maybe 8-10 years ago now already, which really makes me a dinosaur's dinosaur. But I was coming up one morning at Bell Labs in the elevator, and there were some people in the front of the elevator that I didn't know. And they were discussing some young person that just got promoted. And they were saying, they say he's the new Bob Lucky. What does that make me? So as I left the elevator, I sort of pushed past these people, and I said, Once I was the new Bob Luck. And you're like, who's this guy? Crazy guy. I actually have lots of dinosaur stories we could go through, but you know, I mean, and I hate to use up all our time, but I have one more. My 25th anniversary at Bell Labs, I came in that morning to the office, and as a joke, somebody had put at my desk a giant 7-foot green blow-up Godzilla. So there's this Godzilla sitting at my desk. And it had papers in front of him, like his working way. It was really pretty neat. And during the morning, I sat in a side chair and let the Godzilla occupy my desk. And people came in during the morning to see it because it looked so funny behind my desk. Maybe no funnier than I did, but anyway, it was there. But after lunch, I really needed to get at my papers and my desk, so the Godzilla had to go. And the question is, what could I do with this 7-foot Godzilla? And then I had an inspiration. I pushed this Godzilla out into the hallway. A couple of secretaries were running behind me. And over to the elevator tower. I pushed the down button. I worked on the 6th floor, the top floor of the building. When the elevator doors opened up, I pushed the Godzilla on the elevator, pushed the basement, and got off. So the Godzilla went down the elevator by himself. See? Now, what I really wanted to see was the faces of the people waiting for the elevator in the basement. When the doors open and there's this Godzilla in the elevator. So I started running down the steps. The secretaries had already run down the steps, so they were going to they made it to the basement to see what it looked like. But it was very clear that I didn't have enough time to beat the elevator to the basement. So I reached the 3rd floor, and I ran over and I pushed the up button in hopes that I could somehow intercept my elevator going back up. Because there are 4 elevators, so I got a 1 in 4 shot. But it was my lucky day, and it was my elevator, and the doors open. I'll never forget the sight. The elevator's packed with people, and they're in the middle of all the people. And nobody's even smiling. I think, if you want a word of what corporate life is like today, if you had a picture of this Godzilla in the middle of all these things, really couldn't care much about this. That's what it's like sometimes. Now, the Bell Labs in the old days, in the days of Shannon and everyone, Shannon rode around a pogo stick in the aisles, he juggled, and people did crazy things. And that is not in the corporate environment these days. It's really quite a different thing. Actually, I'm here to talk about some technical stuff. Not much, though. How's the time doing?
Got an hour.
Well, no, that wasn't. I thought maybe it was up. In fact, I always, you look at the camera. You don't go anywhere these days without being videotaped. Right. Hi, videotape. But some years ago, I went to give a talk. I got asked to give a talk at a committee meeting in Washington. Well, I remember it was a Data Transportation Committee. So it was like this. I didn't prepare any talk at all because, I thought, it's a little table of people, and we'll just chat over lunch. So I got this place. It was in Washington Hilton, and I got down there, and there's this grand ballroom. There's 1,000 people, and I have no talk. But the worst thing was that there was a desk in front of the ballroom, and they were selling copies of the tape of my talk. So I started my talk by saying, if you have just bought a copy of this tape, you have been screwed. Get that? I want to give a few observations about what's going on in telecommunications today. Won't be very technical, like being a dinosaur. But very interesting things are happening. 15 years ago, I used to get all my information by reading technical journals. And today, you got to look at the Wall Street Journal, New York Times, find out what's going on. Yeah, I wake up in the morning, I go out with my 2 little dogs and get the newspaper, and I open it up and I find what companies merged with what company, who's unmerged with who's bought whom, who's announced this or that. And that's what's sort of making the world go around. It doesn't seem to be in the technical journals anymore at all. I mean, it's these cataclysmic events, and I feel like sometimes I'm standing on an Arctic ice floe, and it's spring, and I hear the cracking of the ice out in the distance, And I know where I'm standing isn't safe, because that's the way it is these days. There's no place that's safe. Things are happening in the world. Things that you can't control. Cataclysmic events. And I'm not going to talk about all these kinds of things, but, forces that are happening about me. They're caught in the middle of all these things and trying to make sense of it and say, what should we do? In the good old days, back when dinosaurs were in flower, I and people like me felt that we could do what was best for the country. I mean, we were in the Bell system, we had a monopoly, we could design the best telecommunications for the country. Nowadays, the situation is completely different. The market forces are about us, the things that are going on, and sometimes you feel like pawns trying to make sense of what's happening. Very powerful things like the digitization of media. Everything now is reduced to bits, ones and zeros. And what does this mean to life? The fact that pictures, television, radio, computer files, everything is now represented in terms of immutable bits. In fact, I gave a talk a couple weeks ago at MIT. They had a course entitled, here's the title of the course. That's my addition here. But the title, of course, a bit is a bit. In fact, it was interesting, the course is given by the Media Lab at MIT. And Media Lab is, some people consider not a part of MIT, and they sort of signed a peace agreement with MIT. And one of the agreements in the peace agreement was that they actually had to teach a course, which they hadn't done for 20 years or ever since. And so they're clever people that run the Media Lab, and immediately what they did was sign up a bunch of guest lecturers like me. But and 1,000 students sign up for the course, based on a bit is a bit. Because this is probably a powerful concept. But it's certainly giving us a lot of trouble in terms of legal, ethical, intellectual property rights, things that are going on out there in the world that have to do with this digitization of media. Now, when you take, and I want to argue for a minute whether a bit really is a bit, and I got to get on with some other things, but picture there's an optical fiber out there in the telecommunications network, and somebody cuts a fiber like this thing. I always picture the fiber writhing on the ground as a bit squirt out the end. But as the bits go out, and you can't tell what the bits are, whether this bit is a piece of voice, whether that bit is a piece of video, or if it's from a computer file, whatever as they go by. And the thing is, they're all the same. I mean, a bit is the most anonymous creature in the universe. It's a 1 or a 0, has no other property. I mean, it's nothing. It's not purple or green. It's just a 1 or a 0. There's nothing to it. It's the most elemental thing there is. And they're all alike. So a bit is obviously a bit. Well, being an engineer, you like to argue these things. Bits are not all the same. For one thing, picture you've got the bits are pouring into a router here. And the router has got to direct some bits this direction, some bits that direction, as happens in telecommunications systems. And you could get congestion there, just like you do in the freeways. And stuff has to be stored and buffered. And here are all this anonymous bits in there. And then one bit raises its hands and says, wait, I got to get through before that guy. You know, I'm a piece of a video picture. And if I don't get through, the picture gets broken up. That guy's email. He doesn't have to get through. You know, a bit, not necessarily a bit. Now, then the second thing is, you know, we ran into Nicholas Negroponte tried this bit as a bit thing on a bunch of entrepreneurs who are doing multimedia authoring stuff. And they were astounded that anyone could be so naive as to think a bit was a bit. They said, what a network centrist view. My bits are better than his bits. You know, I worked really hard on my bits. My bits are valuable. Our competitors' bits are inferior. You're not worth so much. How can you possibly think that all these bits are the same going through there? And then yet another property that's different is, Len and I were arguing at lunchtime with some other people. You know, the fact is, they cost vastly different. Those little anonymous bits going through as they trickle through, if one of them belongs to video, it may cost 1,000th as much as the next one, which belongs to voice. And we don't see any way around that. Because if you pay voice prices for video bits, nobody could afford video. It would cost 1,000 times as much as voice. Now, on the other hand, if you charged video prices for voice bits, voice would be free. So as the bits come by, they're like airline seats. You know, there's a frequent flyer miles we use for that bit. You know, this is a tourist class bit, that's a first class bit. They're going to cost different kinds of things. And a report that Len is helping to write for the National Academy, you know, concerned with the unbundling of prices. And yeah, sounds good, doesn't it? Yeah. Very difficult. And in these kinds of themes, we recognize that telecommunications and technology in general today has been interwoven with social themes. I could add to that certainly education, teleeducation, the IVHS, by the way, is the Intelligent Vehicle Highway System, but traffic, social issues now are cross-cutting across communications. It's no longer just build a better communication system, but what is it for? And that interacts with the design and the philosophy of the communication. As we go along, I'm going to come back and talk about this National Information Infrastructure some, because that's the cause célèbre in Washington these days. Thanks to Vice President Al Gore. And you know, you can't go very far without hearing about the National Information Infrastructure today. It's one of the few things that in Washington that everybody agrees is good and that they're in favor of, and that nobody knows what it is. And of course, these things go together. Let me talk a little bit about technology here, but very little, because technology in many senses is assumed to exist and not to be the problem. When we look at transmission, the fact is that it's just getting damn cheap. That these bits are going to be so cheap that there's no money in sending bits anywhere. And there's something like AT&T and everybody's got to worry about. But this is dropping exponentially at a factor of half per year. I mean, it's going down by a factor of 2 every year. The cost is dropping exponentially. And will continue to do so for quite a few more years, because the capacity of an optical fiber, as you may have heard from Paul Green was here and talked recently, but yeah, it's probably 1,000 times bigger than what we use it for today. And so there's a factor of 1,000 left in the optical fiber to be exploited. And since there's no technological reason, no real good one that we know, that you just can't keep going down, I'm sure it will. Now this is like the highways are getting twice as many lanes every year without anybody doing anything. And you ask, well, I mean, what's going to happen because of this? If this is one of the inescapable laws of life, and by the way, one of those laws of life, when Len was putting these together, that always bothered me was the fact of constant change. When you're an engineering student, you pictured that it would always be these vacuum tubes that for a nickel would dime would light up or whatever. I thought the world would always be like that. And in schools, I don't know what they teach at UCLA, but most people when they got out of school in my day, and many people since then have felt that in universities they were taught that things had always changed in technology, but now they were okay. This is the way they're going to be. And when you come out of school, you have this idea that now you know it. And you can go out and do this stuff. And you don't have built into your very gut the fact that it's going to keep changing so fast that your degree is going to be worthless, in just a few years. And I always live in fear, used to live in fear, I'd gotten past this, that they would be, one day there'd be this registered mail for me at home and there'd be a recall on my degree. Defective, but you see what's happening here. And what it means is that bits become free. And so you think, well, what does that mean? Does communication become free? And no chance. Because basically the cost of communication has to do, communication service business. The cost of all the technology, all the transmission, the switching, all the multiplexing, everything a telephone call costs less than the billing you for that call. The fact is, you see, that the technology of communications is trivial when it comes to cost. The cost of this is the 1 million people that run the telecommunications networks in the country. It's paying for them, and that's why you keep reading about how they're firing all these people. It's a people and service cost business. But what's going to happen is that communication will become the pricing, or at least the cost of communication, will become relatively independent of distance and bandwidth. Go as far as you want, and use as much bandwidth as you want, because this isn't what costs money. It's rendering the bill. It's making up, doing all the accounting, maintenance. Everything has to do with the call. So the situation right now is that a lot of people, the majority of people in telecommunications don't care about transmission anymore. Now, I'm an engineer at heart. I love this stuff, and I love to think about optical transmission. It's a miracle that you can have a laser that's smaller than a grain of salt, can be turned on and off billions of times a second, and that little pulse of light can be seen for 100 miles through a hair-thin fiber that has a transparency, better than any transparency that we've ever known in the world. This is an incredible miracle, and people don't appreciate it anymore. They say, yeah, what have you done lately? They take that for granted. And they say that, in fact, it's too good. Look what you're doing. You're knocking the economics of the business out from underneath us. Will you please stop this? So that, in fact, what's happened lately, even AT&T that sells the optical equipment is moving out of that kind of business. And they're not so much interested anymore in making better transmission systems. This is after 100 years of working on open wire transmission and wireless, and going through microwave and coaxial cables and so forth. It's just got too damn good. And the problems lie elsewhere. Now, one of the big problems right now is the distribution of getting this broadband communication to where you are, out to the homes of the country. And that's where the bottleneck, both economic and technological, is today. Now, you probably deserve a whole talk on this, but I really just want to pass over it. But there are lots of ways that you can get broadband out to homes. Some of them involve putting fiber optics out to the home, like this fiber to the curb business, where you put a fiber right out to some optical network unit right here, and then you go out copper. Because if you run it all the way to the home, that really gets awfully expensive. But if you run it just to the curb and let, say, 4 to 8 houses share the fiber, that makes the economics feasible. But in terms of economics, what we're talking about here is that to put a copper loop into a home costs about $1,100. And again, the cost isn't really in the technology, it's in digging the trench and having the workmen go out there and all that kind of stuff. To put a fiber broadband out to the home costs about $500 more. Now, but if you multiply that by the number of houses in America, figure some learning curve, stuff like that, you get to a cost that's estimated at about $25 billion cost to wire the homes of the country with optical fiber. And so that's a large amount of money, but it's not undoable, and that's certainly the direction that is now being taken, and there are many experimental and systems that are going in. But it's going to take maybe 10, 15 years. In fact, at the current rate, it'll take 15 years to get the majority of the homes wired for fiber, and it'll take this $25 billion. But the good news is that we're not going to do it just once, we'll probably do it 3 times. And 3 times the nation will pay for this being done. And the reason is it's in the good old American tradition of competition. That you'd think one fiber would be enough for your home. Like, do I need 3 electric utility lines coming into my home? I seem to get along okay on 1. I haven't tried 2 or 3. But in the case of telecommunications, you're going to get 3 fibers probably coming to your home. 1 will be brought by the cable TV people, 1 will be brought by the telephone people, and 1 will be brought by the electrical power utilities. You know, and you'll pay for all of them. And the theory is you'll benefit because you'll have competition then in the services and so forth. Now, yeah, there are people in Washington, very few, who believe that it would be better if there was just one monopoly that took the line into your home. But nobody believes that works anymore. Everybody believes that competition has to be the way it's done. And so you pay for it 3 times. But that's the only way to spark vitality in the marketplace and to have lower prices in the end. Now, there are also architectures that have a combination of fiber and coax. And this is cable TV type architecture where you have fiber out here and then you have coax bus there. And then there's another possibility, and that is to use the existing copper pair into the home and to put special modems on that pair that upgrade it to send approximately 6 megabits per second into your home. And at that rate, you could get 4 digitized television pictures in your home. A few companies, notably Bell Atlantic, think that they believe in doing this because the copper wires are already there. And they don't have to put any big investment to put a fiber or anything like that. They just put a little modem in your home, this ADSL. ADSL stands for ADSL. You don't even want to know, because I mean, it's silly. Sometimes the acronyms stand for things that are, you might as well just know the acronym. Okay, so anyway, you have this ADSL modem in your home and one in the office. Now, when you want broadband, you just call up and they give it to you the next day. They don't have to put any big investment. They don't have to dig a trench. They don't have to put a fiber in. They don't have to worry about the economics of how many people are going to take service over that fiber. One thing and you're up. So it sounds like a great thing. Now, the problem, though, is that the bit rate is limited because you can only get 1.5 to 6 megabits per second over this copper cable. Now, a digitized television these days, you get VCR quality television at 1.5 megabits. You get network quality probably 3 megabits, something like that. So you can actually get network quality in your home over your existing telephone line. 1 or 2 channels. And you can really, and there are systems like that we have set up. Bell Atlantic is playing with it and stuff like that, where you can actually work as if it were a VCR control that you have. Because what happens is you fast forward, the information is sent back to the central office, they just fast forward on your line, or you can stop it, still frame, anything you want to do, you control it. Because the video path, and then you have this control path going back to the thing. So as far as you're concerned, it might as well be a fiber, because after all, a bit's a bit, isn't it? A bit doesn't know whether it came over a fiber, whether it came over a copper wire. It's just, it's just a 1 or a 0. But I think people fear that if you actually did this, you'd get killed with advertising. That Sprint would say, you can hear a pin drop on our system because it's optical. And this inferior thing, that comes over a copper wire, I mean, obviously inferior. Inferior bits. And most of the public would believe that. And even I would worry. You know? Are you getting high quality bits or, you know, I mean, and yet, for everything you see, it should be the same. But the idea that the guy next door to you with the fiber has a fire hose coming into his house, and you have a drinking straw. And through the cleverness of engineers who have been able to compress the video picture and so forth, your drinking straw is going to do as good as his fire hose. Now, not even I totally believe that. So I think that's kind of difficult. But here's where there's a lot of activity, because this is where the money is to be made. And the money is to be made not by bringing you the information highway or anything like that. The money is bringing you movies and home shopping. You know, that's where the money is, and that's what the telcos want to do. They don't care about telephone service anymore. Telephone service, it's a losing business. But the golden eggs lie in this video on demand, bringing the electronic video rental store to your home. So that's what they want to do. They're motivated to go out there. They want to own the content. They want to be your blockbuster, your electronic blockbuster right to home, because that's where they believe the money is. Now, my personal opinion is that's where the money is. And the problem is maybe the only place where the money is. How much you're willing to pay for information in your home. You know, they always talk about accessing the Library of Congress from your living room. I mean, how many people really want to do that? You know? The problem is people want to see the movies, and that's where the money is. Now, as I look for other things that could be moneymakers, I mean, there's games. Games is but it's a demographic niche. Games are a young teenage male phenomenon. 85% of the market are teenage males. You know, and that's really it. Home shopping. Now, there's something I was completely wrong on. I mean, I'm often wrong about stuff. And I never thought that home shopping would be a big deal. I thought shopping was a social experience. You go to a store, I couldn't picture buying serious stuff from my TV set. And yet, I've been proven wrong. Has anyone here ever bought something from home shopping?
$5 Chinese imported Swiss Army knife.
That's great. Wasn't it any good?
What do you expect of a Chinese Swiss Army knife?
That's great. That's really great. I occasionally ask audiences, how many, and usually it's about one person in the audience that's actually done this, but I understand it's really a social phenomenon also, and that was really to capture that essence is something. So there's a model for making money, and this is what the companies are motivated to do, is to bring you movies on demand. This is where the action is. And that's why they want to get this broadband pipe out to your home. Not any grand purpose in any national information infrastructure. They don't care. They don't know where the money is in that. The money is bringing the movies into your home. Now, there's another way into your home that I don't want to pass over, and that is the whole wireless thing. This is another thing that we in telecommunications have often made a mistake about. In about 1987, something like that, AT&T hired a consulting outfit to do a study of the demand for cellular telephones. And this consulting outfit was given a couple $1 million, and they came up with this study that said that there was basically no demand for this. Now seriously, and AT&T decided not to get into this business. And they were proven completely wrong. And this goes to a problem that's always frustrates me, that we really have no good way of knowing what services are going to be wanted by people and what won't. And the worst way seems to be to ask people what they want. They just don't have a clue. And the second worst way is you run trials and give people these things, and the people feel really singled out. You give people some free information service in their home, and then you go back and say, how'd you like this? Oh, wonderful. Wonderful. Would you pay for this? Of course. How much would you pay? $10 a month. That's what they always say. And then you give them the service and send them the first $10 bill. And they say, take this thing out of here. So wireless has definitely taken off. And I was one of these people that back in the old days, take cordless telephones. I mean, what is the big deal? You don't need a cord. I mean, what's wrong with having a cord on your telephone?
It's true.
But people like it. What can you say? It makes a lot of money. So anyway, the world is sort of going wireless. And one way is and what they're doing like in Eastern Europe right now is to say, instant infrastructure. Why, if you don't have the wires buried in the ground, why put them there? Let's do it all with radio. And so there's personal communication systems, PCS, and there's WACS, wireless access communication systems. And the plan here is that there would be wireless-based little small base stations about the size of an oatmeal canister kind of thing, hanging on sides of buildings and lampposts and stuff like that. And pedestrians up to 2,000 feet away would talk on personal telephones to these little base stations. Inside buildings, you'd have indoor stations, and maybe 200 feet away, in buildings like this, you'd have these around and so forth, so that the whole world could work without wires. And this actually is being done. The standards are being put in place. Companies like Motorola and Hughes are already building equipment, and these will be low power, long battery life, lightweight terminals, and we're approaching the Dick Tracy telephone, but I have kind of a problem with that. In that I've always aspired, you'd like to have these goals of what you'd really like to do, and I always thought to have a wristwatch telephone you could talk to anyone in the world would be the best thing. Until one day I thought about, what if the whole world could call my wrist? And I realized that, I don't like that idea. And one of the problems I'll just in passing mention that I think is really important in telephony today is that of agents and surrogates, filters, mediating communication between people. Because basically, there's a real paradox here. If you want access to the world, how can you prevent the world from having access to you? Because otherwise, it doesn't work. If everybody takes that same attitude, everybody has to be either always accessible, or else the whole thing doesn't work. So how do you mediate this? And I think that certainly is one of the problems that's receiving a lot of attention and a lot of intelligence going on. But in terms of wireless, we're going to have various types of access, and they're going to coexist. We're going to have today's cellular systems, both the analog and digital. We're going to have this new wireless access communications. We're going to have handsets that can talk either language. And we're going to have satellites systems like Iridium. Iridium was supposed to have 77 satellites in low Earth orbit, and it was going to cover the whole world. It's down to 66 or something like that. But the idea, and we read recently, another one of these big announcements in the paper of Bill Gates, getting together, because he's got all this money, what's he going to do with it, Anyway, they're getting a system that's supposed to have, 3,000, I forget, how many? 800. Yeah, it's some very large number, obviously, 800 satellites. And sure, you can do this, and if the whole world agrees to buy into this, then it works, and you get rid of all the stuff. But the problem is if everyone says, well, I'm going to use the lines I already have, and then you put all these satellites up there, and then the first call costs $10 million. And it's a real chicken and egg problem how you ever get this thing started. So it's a great gamble, and I don't even understand the economics of Iridium. Basically, the target market are all those people in the world that have no money. It's the jungles of Brazil, Antarctica, stuff like that. Places where there's no existing infrastructure, but because there's no existing infrastructure, nobody has any money there either. So I'm not sure how this all works out. Now, I'll tell you what, I'm going to skip over all this stuff. Well, some of it. Look, I mean, won't cheat you completely. Let's skip some of this. One of the great movements, I want to do two more things in the time I have left. I don't want to abuse your attendance here, because I appreciate you coming out to hear this. But I'd like to do two things. One, I'd talk about, very briefly, one of the great themes in telecommunications today is ATM. And that's a packetizing of communications. And I don't want to let this pass by, but then I want to really talk about this national information infrastructure on internet and the relationship between internet and the existing telecommunications network. But packet switching is an idea whose time has come. Now, packet switching is something that people like Glenn have been messing with for a lot of years. And we've always said, hey, that's a good thing, but it's nice for academics, why? Well, this has no bearing on things. And only in the last couple of years, suddenly has a fire caught here. And something called ATM is coming along. Now, ATM stands for ATM, as you knew, and not automatic teller machine. But it's a really packetizing of communications, and many of you know a lot about this. But, why packet switching in the first place? Packet switching, you really get efficient multiplexing of disparate sources. Now, everything's now represented as packets of data. An ATM is 48 byte packets. In fact, look, here's an ATM cell. You got 48 bytes of data in a 5-byte header, and now everything is one size fits all. Everything is now represented that way. It's a total different paradigm for communication. Instead of having a wire between me and you when we talk on the telephone, packets float out there. I started to say aimlessly, but they aim, and they go around. So anyway, but because everything is fit into cells, you can mix sources of different rates, different burstiness, efficient multiplexing. Packet switch gives. It's easy to achieve bandwidth on demand. If you want to get a computer file of 1 megabyte through right now, you just drop all these packets into the network and they will zap through. So that when you need it, the network is there. And now, a picture, it's like having the whole fire hose at your disposal for an instant. Versus having a fire hose filled with little drinking straws. And to give that megabyte file today, you've got to blow through the drinking straw for a long time. In a packet network, you drop the whole thing and it just goes through the fire hose in just an instant, and then somebody else gets the fire hose. So flexibility in common format. So those are the good things. But there's some things wrong with packet switching. One is a variable delay. As these packets flow through the network, and if they represent my speech signal, you need to get these packets to arrive regularly at the other end. And if they float and one gets stopped here for a minute, another one takes a different path, goes a different time. If they take different times to arrive, the speech is broken up. So this is a problem with packet switching. And some cells get lost. And plus the fact that when I set up a call in today's telephone network, the switches are all set. And just think of them like relays, because that's really all they are, virtual relays. And once the relays are all set, then I set it and forget it. My bits float through to you over the paths like railroad connection. All the switches are all set and it all goes. But in a packet network, I got to open up every packet, read the header to see what to do with every little chunk of thing going by. So it seems to take a tremendous amount of processing. So for those reasons, we really haven't done packet switching until now. But in ATM, first, to try to get around these difficulties, first, a fixed size packet. That simplifies processing. And second, virtual connections. So that what you do, it's not every packet floating independently. You establish a connection. And you say, I want to talk to Len. And then there's a route established. And then every subsequent packet just has this address on it. And the switches are, in fact, already set. And the packets can float through the LAN, all by the same pathway. And because of that, having the same pathway, the delay is much the same on every packet. So that this connection-oriented approach is able to get around. Now, I don't want to handle some of those other things. But basically, the world has suddenly decided this is really a good way to do communication. So it's a grand opportunity to rethink and re-engineer the entire telecommunications network based on a complete new paradigm. It's an exciting thing that's happening. And it's happening with the computer industry because they're building LANs right now. And they're building cards to plug into Sun workstations and stuff like that, to adapt them to ATM. ATM is fast, it's where it's at, and all of a sudden, you've got a whole new communications infrastructure rising based on ATM. And because of ATM too, switching is becoming cheap, just like transmission was becoming cheap because of optical fiber. And if you look at the cost of switching a packet, in 1985, which wasn't that long ago, it cost about $1,000 per packet per second. That was an IBM 3725. Today it's down to 1 cent per packet per second, and going down very fast because of modern VLSI technology. And so everything's becoming cheap. So you ask, why did your telephone bill go up? So finally, I want to talk about National Information Infrastructure. This actually is from Len's report. And I know if he were standing up, which he isn't, that he would say, geez, there's 15 people working on it with me and stuff like that. But anyway, you might recognize this from the preamble of your report. Soon to be released on the bestseller list, I'm sure. But what are the drivers of the National Information Infrastructure? First, the administration's promotion of this. Second, the runaway growth of the internet. And third, the thing I've been talking about a little, is this sudden recognition of the commercial marketplace of the entertainment market potentiality here. Now, it's the melding of these together that really is going to decide what happens. So I want to dwell on the internet problem for a while, because I see the internet is a completely different model for telecommunication. And what has happened here is something that's fantastic. And it's also scary in a lot of ways for anybody whose livelihood depends on the existing telecommunications infrastructure. Now, everybody here, I'm sure, uses internet. It's not an audience I have to talk to about internet, but you always pass through some figures. 25,000 networks. One's connected, I think, every 20 seconds or something like that. Over 2 million computer hosts, 146 countries, and it's doubling every year. And at the current rate, the one figure that puts this in perspective for me is at the current rate, the number of users of internet in the year 2001 exceeds the world's population. 2001, not that far away. Now, and then there are people that say, well, why stop there? And in fact, fascinating, in the book, The Mind's Sky by Timothy Ferris, he gives a good argument that when we finally achieve the search for extraterrestrial intelligence, that when we do talk to alien beings, that we won't just establish a communication link with them, but we'll be talking to an internet link in the sky. And that the way to communicate with other intelligence is not to set up a thing and beam it out into a random space, but to build a network node that's self-replicating and send it out there. And let it just sort of self-replicate and distribute itself around the universe, setting up an internet out there in the galaxy, waiting for someone to talk to it.
Suppose that humanity's greatest achievement be the propagation of Usenet?
I'm not sure how to answer that, but how many of you read Usenet, read the net news stuff? Come on. I read it, and it's somehow floating in all that info junk is good stuff. And I've always said that, to me, it's a really interesting social experiment, because I always had this idea. I would love to have visited and lived with the Paris coffee shops in the 1920s. You went to this little club, and there were the great thinkers of the world, sipping coffee. And you could sit down there and discuss philosophy with them and stuff. And I thought that'd be neat. And in some sense, the Usenet groups could be like that, But it's like, I don't know, who was it that said, probably not Yogi Berra, but you know, he wouldn't want to be a member of any club that would accept him. You know, who was that? Groucho Marx. Yeah, right. Well, those are kind of like that too, and that is they got overwhelmed with junk. The problem is the coffee shop doors are open to everybody, and sure, there are all these great people of the world are sitting there, but then the other people come in, and pretty soon, you know, the noise level rises, and nobody hears these great people of the world, and they slip out the back door, you know, and so they're not even there anymore. And so what they do is they start their own little discussion group over there, and for about 5 milliseconds, it's a great discussion group. You know, until the riffraff of the world discovers that the great people have gone over there. You know, it's like discovering great restaurants. As soon as they get reviewed and written up, you know, then they turn no good. And that was a Yogi Berra thing he said about some restaurant. He says, nobody goes there anymore. It's too crowded. So, I mean, if we look at the architecture of internet, you know, what's inside internet? Here's me. I sit at Bellcore, and I'm on a local area network here. And in fact, there's a corporate network bound together a number of local area networks which are interneted. And we have a router right here. A router is a little box about so big. Cisco router costs $30,000 to $50,000. And then we lease a lease line, T1 line, 1.5 megabits per second from New Jersey Bell. And this is 35 miles long, and it goes down to Princeton. And that costs us $7,000 a year. And then we connect into JVNCnet, which is a little company, one of these mid-level companies that have formed that connect people to internet. Internet, this is the backbone run mostly, but not entirely by NSF. And largely, but not completely free. But anyway, JVNCnet started, John von Neumann Computer Center. It started at Princeton Computing Center, as many of these did, and then it got a little bit too big, and they made them move across the street. They hired graduate students. Pretty soon, they had to get some full-time employees, you know. And it's a small outfit, but they get $35,000 a year from us for the privilege of connecting us to internet. And I pay $7,000 to New Jersey Bell to connect us to that. So. And I spend about $30,000 a year maintaining that router that puts us into that. So a total cost of $70,000 or something like that. We got 3,000 people sitting here getting as much communications as they could want. And it comes down to pennies per month per user. You know, I mean, it's an incredible bargain. The same people that are paying hundreds of dollars per month for the telephone company are getting all of this very adept computation, and with the advent of Mosaic, by the way, is growing at 11% per week. And at the current rate, Larry Smarr, who runs the director of NCSA at University of Illinois, says he'll need 100 million servers for Mosaic at the end of this year. You know, I mean, something's going to happen. Of course, he won't. But I mean, how many use Mosaic? Oh, about everybody who serves internet uses Mosaic. I mean, great, isn't it? You know, and that opens up to multimedia and everything. I mean, so I think it's a great discovery that's a whole other social phenomenon that's happened. I mean, why could Mosaic spread so quickly? And there are a couple of reasons. First, it was really needed because it was a human interface, you know, hypermedia, and hypertext link. So it was a very powerful but very human interface to internet. It was needed. Second, it was free. And third, it was a real example of how the net itself can spread software throughout the world almost instantly. When you've got a good piece of software that's free, it can propagate the world in a few months. It's probably, I think, about 2 million users right now on it, and just an incredible phenomenon. Anyway, so here we pay pennies for this incredible capability in internet, and we pay hundreds of dollars. That's an exaggeration, but you know, there's certainly orders of magnitude different for our telephone service. And you say, why is it so different? Why does one cost so much and the other cost so little? And we argue this daily, and I've never argued this with anyone who had the same view as I did. In fact, no two people seem to have the same view as to what's going on right here. But the important thing is we have two different paradigms for what a national information infrastructure might be. One is internet, and the other is a telecommunications network. And neither one's quite right, but somehow out of these two is going to come a national information infrastructure. Now, the thing you notice immediately about internet is basically there's nothing inside. That there's nobody home on the internet. I described the world's telecommunications system, or the nations, as having 1 million people working there. In AT&T and MCI and Pac Bell and all these places, there's 1 million people out there. Now, on the internet, nobody. I mean, basically, nobody runs this thing. Not only is nobody in charge, but I mean, there's nobody out there really running it. I mean, you have a few routers. These are $50,000 boxes. They're not $10 million switching offices. You know, they're just little boxes. And what has happened is all the intelligence and everything has been pushed to the periphery of the network. They say, hey, you got to do your own thing. So actually, it's sort of hard to get into the internet from your home right now, unless you go through a friendly server, someone that's going to support you. But if you're a corporation that can support access like that, you get the thing largely for free. So actually, internet violates 2 rules of life that someone once told me. And the question is, how does it get away with this? A question, by the way, which I'm not going to answer. Partly because I don't know, and I actually have had serious economists, a staff of, PhD economists working on this, trying to understand it without noticeable success. In fact, we're firing all these economists. But if you look at this evolution to a national information infrastructure and compare internet with the telecom, first internet is interoperable for data, whereas telecom is interoperable for voice. The way the telephone network was made and glued together, I mean, you can call anybody in the world. And the way you call is to plug together analog voice channels. That is the meeting point. If you want to join the world's telecommunications network, you've got to have a plug that has a 3 or 4 kilohertz voice channel, analog, and plug it in you're in business. And whenever you have to interconnect 2 telecommunications systems today, you have to unbundle it, take it down to voice channels, and plug all the voice channels together. And then they're plugged together. Now, internet is plugged together at the IP level, at the packet protocol level. The connectionless IP internet protocol, so that we speak of internet as being sort of an hourglass, because at the bottom it supports any kind of physical access. It could be ATM, it could be wireless, fiber, whatever it is. But as long as you speak IP packets, if your data comes in the form of these packets, you're plugged into the internet. So if you're in Mongolia or Pitcairn Island, who have networks that are part of this, that's all you got to do. You buy a router that speaks IP, you plug it in, you're in business. So the difference in where is the level of interoperability? Now, as I said, internet, the intelligence is at the periphery, partly because the computer people who built this couldn't get inside. That was the province of AT&T, a telephone company. So they said, let's just build something that works from the outside in. And whereas telecom, they're really proud of all the intelligence they have put inside the network. This is a smart network. I mean, they advertise it that way, intelligence. And these giant switches with all these, the average telephone company runs on about 20 million lines of code. There's a lot of intelligence and stuff out there. Whereas on the internet, there's almost nothing. Now, in the telecom, they've made it robust and stable. Whereas on the internet, you have a class of service known as best effort. And that's seriously, best effort. If you put a packet in there, hey, we're going to do our best. And if it doesn't come through, well, I mean, you're not paying anything for this anyway. But there's a, as it points out in your report, Len, there's a place for that. A lot of computer applications run really pretty damn well on that. And why should you pay for robust, stable service if you don't need that? Whereas everybody here is forced to pay for this. Now, telecom has 1 billion users, internet has 20 million users. The question is, does this scale up? Is this really going to work? When you try to put 1 billion users on the internet, is that actually going to work? And frankly, nobody knows the answer to that. The internet has 100% annual growth. Telecom is 3 to 5%. Very slow. Basically, almost no growth versus explosive growth in the internet. I want to skip down to billing. telecom, we've got very sophisticated a la carte billing. In internet, yeah, you just pay for how big your pipe is going to internet. $35,000 for a T1 pipe. If you want, at 56 kilobits pipe, it's 20,000. It's just pipe size, and then you do what you want to with it. There's no other charge. There's no usage-based price. Whether it can continue to exist like that, or whether it even should continue to exist that way, remains to be seen. Some people would say that, that this isn't worth what you pay for it. By the way, one of my friends here gave me pricing philosophy of telecommunication based on restaurant prices. Now, there are different models for how a restaurant charges you. One model is the a la carte pricing. You pay for every dish that you get, and that's usually the way they grab you. The entrees look cheap, but by the time the final bill comes out, how did you get to be so much? And you discover coffee was $5, and stuff like that. Roll, roll! Roll! That kind of thing. So, a la carte is one, and that's what the telephone company has right now. Now, another model is, all-you-can-eat model. $12.95, all you can eat. Now, you might think that's internet, but no. My friend said that the internet is like if you ask your children about restaurant prices. They don't even know. Hey, Dad pays. And that's what internet usually does. I would say the vast majority of internet users aren't even aware that anybody pays for the thing. Now, telecom, and here we get to one of the real, this just looks like something you'd pass over, but it's very critical. Telecommunications is regulated, and the pricing in telecommunications reflects social policies of universal access, equity of service and access, and to do so that the farmer in Montana pays the same as somebody living here in Westwood or whatever, and it's that. So the pricing is a social policy. Internet never was regulated, so they haven't had to worry about the social problems. Now all of a sudden, making it the national information infrastructure, the biggest arguments in Washington today are universal service, equity of access to internet. There's all these special interest groups, and every time I think I understand this, I go to Washington, and there are all these people that show up, the disabled Americans, the rural advocates, the retired persons advocates, the consumer advocates, and they all have a position. I heard that at Gore's meeting last week or something, there was a disabled group said that we couldn't use keyboards because there were people that couldn't use keyboards. So, should not let other people use them. To have a special advantage like that. So, and it's serious. You go there and you'll find that these serious things happen. So, and one of the problems is right now that there's an action before the FCC and bills to regulate telecommunications in Congress that both call for looking at the internet and seeing what to do with that. Now, my view actually is that the internet is bigger than the U.S. government. And the things are happening out there that are bigger with them. And I always think it's ridiculous. I sit on committees in Washington, and you debate how things ought to be in the internet and stuff, and it's all a charade because it's out there happening. And they don't even care what the people in Washington are saying. And furthermore, there is no they. Because you can't find out who is actually doing this. So, the two cultures. Telecom, done by communications people, dominated by voice, network-oriented. Internet, done by computer people, dominated by data, and periphery-oriented. Now, they're both models for the national information infrastructure. I'm going to close now. Len said I could take up his introductory time and still have my hour, so I apologize for. No, I don't apologize. Sorry. But we had the two models, and neither one is perfect right now. Internet, I've been pretty easy on internet here in what I've said, but there are problems with internet too. Scalability, of course. The whole pricing model is a question of whether that can exist. When you put multimedia on the internet, is it going to sync? Right now, there's voice and video on the internet on an experimental basis. The IP protocol is being changed to have them in so that within the next couple of years, you'll be able to make voice calls free over internet. And AT&T is suddenly going to become the giant that was awakened. You know, when you can bypass the world's telecommunication with a free voice call and internet. There's broadcast, of course, internet radio, M-bone video, sometimes brings CNN up. It even raises the question, what does broadcast mean today? And the FCC looks at it and says, well, we regulate broadcast. You know, this looks like broadcast does. And there's the problem, too, that internet is a worldwide thing, not just a U.S. thing. So it's very interesting as to what will happen in the future on this national information infrastructure, where it'll come from, who will benefit, you know, who will assume the risk, who will get the money. Is it going to mean movies to your home, or is it going to mean information? And who's going to do this? Who's going to run it? Who's going to rule it? All fascinating questions, and I think that all of you, many of you, are in a position to have a say as to what happens here and to help shape this. But it's a grand thing that's happening. Thank you very much.